Hello guys and welcome to another tutorial. In this case we will be learning how to create a cool smoke simulation from the new CAP toolsets. So stay tuned and watch the full tutorial. Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop dev, compositing. We will have resources for every type of discipline. I also have a Patreon page where you can support me. I have every single file, I have polls, I have even some tools, guidance. So if you are interested, you may have a look. Thank you. So here we are in the projects file, and this is actually a very simple yet efficient way to work with RBD. So let's begin by creating a cube. This is just a 3 meters cube with some well, this is basically it's standing on the ground and it has X amount of divisions, basically 7 by 21 by 7. I just wanted to make this like a square, right? So what I'm doing here is setting the names. This is just an HDA which basically creates the name. It's way easier than you think. It's just a class attribute on the primitives, and this function is as@name. There is a name with an // with the itoa of the class. Basically it outputs this variable, so hola, you, and so on and so forth. It just creates the name, but there is only one cube, so there's only going to be one name. Then I'm unwrapping this so we can have the UVs, and I'm transforming this so I can do a boolean and I get the inside with this subtraction. I'm creating all the edge groups, and with this wrangle what I'm doing is to create a mask on the top part. Basically I can control this with a ramp, right? This is mask. I'm creating a mountain and blending it with the mask attribute. You can see that you can basically modify the noise with a mask. So after the mountain there is some cutter pieces, some cutter geometry. This cutter geometry was done in reference to a course called CGMA Mastering Destruction in Houdini. It was a very interesting tool. This is a little bit modified so it suits my needs. But basically what's going on is there is a shrink wrap with an ISO offset and scatter with normals randomized, so the cutters go all around and all the cutters have their own UV. And then what you end up doing is just blasting everything that's not in the bound expand of the box, and later on you are also grabbing all that it's inside this and just blasting it out. So you are only using what you need. After this you subdivide the mesh and you add further noises to these cutters. So this is a very efficient way to work because you only end up using what you need. So yeah, huge shoutouts to Keith and go watch his course on destruction. The same goes for the shattered wool geometry, but in this case it's just one object. For multiple objects, what this tool creates is for each loop on each piece where you basically just Boolean fracture everything. It's a similar tool. The only thing that this is doing is that per piece is actually taking into consideration where the closest geometry is and Booleaning it. So let me show you real quick how this works. And let's go to the first iteration, which is actually the only one. And basically it's an SDF. It grabs all it needs. It blasts only what it's needed, so it's even more optimized than before, and it booleans everything. But that's the only thing. It is important that the boolean, now you will see, actually keeps the UV attributes in place. So something very nice is that if I were to go one step before. Let's just go real quick to this one so I don't load it again. If we go to the pieces high and then I unpack this and I explode view this, you will see that the inside faces keep the UVs of the cutters. And this is important if you want to project some textures. So let's go one step before. This is going to be the high res. What I'm doing is assembling this into each piece. So this is created per primitive with the name attributes. As you can see, if we go here and we click on the name, we have all the name for each of the pieces which were inherited from the first name, basically this. Then we're going to be poly reducing to create a proxy. So this is an easier geometry on the PC. It's great for simulations. You can see it only has 300,000 polygons. And this is what we are going to be saving on an RBD pack. So we are going to be splitting based on the low and also the high. These are the constraints. If we were to need them, which we are doing an RBD constraint properties and we are setting these to soft and nothing else. We are creating on the low geometry a mask that if we see this closely, it's like an animation on that all the pieces will be starting to activate. And if the mask is bigger than a certain threshold, which in this case is 0 because I didn't set it to anything, so everything that's colored, it will turn to 1. Otherwise, it will be 0. So if you see here, the active will start changing as these colors change. One thing that I also did here is that on the break threshold on the soft, I decided to use an angle of 0.1 and a distance of 1. I will be saving the points. There we go. So this simulation is going to be quite fast. And you will see it will start getting activated based on the points and start falling and crumbling into pieces. You see how it's quite dynamic. It starts to break from one part and not from the other. Also, one thing that I did is to lower the collision padding, the bounce everywhere here, adding a ground plane, and the drag spin turned on, the collision padding on properties to 0.01 too. That way, we can stop the pieces from jumping all around. When I set the points, you will see this is a point representation of the simulation. And what I'm doing here is basically setting the name of the piece name equals to the name. This is because we're going to be using the RBD procedural in lobs. Then I'm setting that the piece name is equal to a place where I'm setting the geometry, which is building plus the name, which in this case is going to be equal to the piece name slash the name again. And this will output the following piece name. So basically what this is going to be doing is to dive into the geometry, which is called building, and inside it will find or look for the attribute called cube 0, 0, for example, and it will move that particular piece. Instead of moving like an instance of the piece, it will move the geometry itself based on an attribute. So this is way faster for the solver because instead of loading each piece individually, it will load everything at the same time, and it's just going to be way faster. Now you need to save this into disk and you will have the simulation. So to continue, we're going to be creating the low transform pieces and the high. Basically, I'm just grabbing the low position, the points, and the same points on the first frame, and then I'm just transforming this. And this is how it looks. Quite nice. As you can see, it's sticking with the constraints and it's looking quite nice. The same with the high, so it should match perfectly. This eye it's also going to go to lobs and it's going to have the same modifications that I did here. So we're going to be creating the piece name based on the name, and the path is going to be the following. So this is the attribute we are going to be looking for here with this. And then I'm going to be setting a name for the geometry. This is called building. So it's just going to be, yeah, it's going to be exactly the same path as I decided to be here. And I'm deleting all the attributes that I don't need in this case. Oh, in this case, these two I just don't need them anymore now that I think about it. And I'm creating here a delivery source. The delivery source, basically, I want the ID. I want a distance threshold of 0.01 because I want very subtle movement with this amount of points and this amount of density. Nothing else. Oh, and the remove and release and remove at life end. You will see that on the first frame, we won't have anything because all the unreleased are being deleted. In this case, this is how it's going to be looking. So this is perfect for the smoke simulation. On the time blend, this is useful for when you want to create a trail, like I want to do here. You see there are 2 points here, and I can move with a lot of detail. If I don't have this one, I just move per integer frame. So it is always needed after a point simulation to have a time blend. Then I'm connecting everything on ID. I'm resampling so I can have more points where the lines demand it. And I'm creating a density. The density is going to be based on the age. Then the density is going to be multiplied by the velocity from 0 to 3 to 0 to 1. Basically, when there is more velocity, I'm going to be keeping the values. And then I want only the tips which are closer to the debris to have the most amount of density. This is a fix. I don't want to have points where I don't need them, so I delete most of it. And I deleted one piece which was going in a very strange place, so I just deleted it. And I saved this to an SDF, and I saved this to BDB. I'm rasterizing the density and the velocity with these settings, and saving everything to this and creating a ground for the collision. So these are different takes on the smoke simulation. So just to see how long it takes to simulate, this is with CPU, which is quite slow. The longer it takes, I mean, the more we simulate, the longer it takes. I don't like it. This is a GPU simulation with a minimal solver. It doesn't even start. Yeah, I almost crashed while trying to use this one. And this is the COP simulation, which is the new sparse GPU solver, and it's quite efficient. I mean, it actually takes longer to visualize this on viewport than simulate it. So let's go to this one, for example, and it's quite efficient. So this is the simulation running. As you can see, it's nice in resolution, 0.01 voxel size, and it's already 180 by 330 and 180 roughly, so it's a nice resolution. And the way it was done, it was quite interesting. So I was exploring a little bit, and what I did to activate the pyro block. So this is quite new, but basically a pyro block is how a simulation is. This is basically a dop solver in cups. And what you need is some sort of points to activate your simulation. In this case, I decided to activate the simulation with the debris points, which were brought from before. I'm not using this one at all. So the pyro block has the configure, and the configure I set this to a voxel size. I don't know why I changed this actually. And on the pyro block begin, I set only a clip on the negative y-axis, just in case. I set everything to BFECC, which is the best thing for in terms of quality, and I only want to activate the BDB based on the density to keep everything as optimal as possible. And this is a way to actually pack for sources. So what I'm doing here is to get the BDB of my source, and I geo to BDB. This is important so you can actually interpret the BDB and send it to the cable pack. And in this case, I get the SDF of the ground, and I get the collision, and I pack everything into a cable pack. That way, I'm not iterating each time, and I'm only sending this once through the pass-through, and here's where everything begins. So let's try to work with this on a lower quality. So what I'm doing is unpacking on the first frame, or on each frame, in fact, and I'm sending the density to an add. It's important that the density of the add is always on the background when it comes from the actual feedback of the simulation, and then I'm setting to the foreground the new one. I am adding the previous frame with this frame on the source. Then I'm dissipating a little bit, and I'm sending this to the next frame. When it comes to the velocity, I'm getting the velocity, and I'm doing the same thing, getting the previous velocity, and I am adding it on top of it. I'm also setting a pyro buoyancy with a temperature, even though I don't have any temperature whatsoever, so it's actually, the temperature is going to be 0. But I just wanted to have this in case I have buoyancy. I'm adding some turbulence based on the velocity. I didn't change any settings. In this case, I added a mass by threshold field, not disturbance, and the control field is going to be the density. And I'm sending the velocity back to the velocity. And the collision is, I'm just setting the collision to the collision. And actually, I quite like this method of creating BDBs. This is very different from DOPS, but it's very, I don't know, I think it's more art directable this way. One last thing is that when you go here, this is what you want to see. So when you go back, so after you finish this, you just pyro process this, so it's easier on the machine, and you save this to disk. And this is the simulation you will be getting. Quite nice. After all of this, you will go to the sub import, and you will get the high mesh. As you can see, his building, it has inside and outside because I get all the subset groups. And with the RBD procedural, what you got to do is to get the points which were already pre-programmed. This is just the simulation points here, and it will be using the piece name. As you can see, you can preview this, and it's very fast actually, as you can see. But if you're going to be using this for render, in the meantime, I mean, you can pre-visualize this with the preview, but if you want to have motion blur, you need to remove this one and just save a single frame. This will work for rendering. If you want to pre-visualize it, you will need to use this one instead. So in the meantime, we are going to be using this one. We are going to be setting the render geometry to building on bump map displacement, because I don't want displacement actually. I'm going to be setting a ground. This ground is just a curved geometry, and merging the smoke over here. The smoke is brought with a volume node, and I'm saving all of the frames into a USD, which is this one. So this is just a USD file with the path of the volume over here, and I'm merging this with a simple merge. I'm adding the materials to the geometry. Basically have a pyro, some network where I control the pyro. I didn't do anything. A ground material, which is just a color and phi of roughness. And the building outside, what I'm doing is grabbing the UV, multiplying this by 3. So if I go and set this to Karma CPU, you'll see that if I change this to 2, it's going to change. If I set this to 44, we're going to be having very small textures. This was to 3, which is nice. I'm grabbing a texture here of an RBD, a roughness, and a displacement. The displacement is set to 0.01, and a ramp, just so I can control how much roughness I have. The good thing about using the bump map for the displacement is that I can get these highlights, and it's actually not deforming the geometry, so I'm not getting issues with the borders of the geometry. I'm setting the same for the in, with the only difference being that I'm color correcting this, so it's actually a little bit darker. See, everything is a little bit darker on the inside. And then I'm setting a light. Then I'm setting a camera, which is actually being animated, and a render beauty. Well, I'm setting these limits, so the smoke actually is a little bit more transmissive due to the volume limits being risen up. And I'm setting the motion blur on, that you will only be seeing this after the render when you use the actual RBD procedural, set to not preview and save to disk. Then I'm saving this once again because it's going to be getting the caches and everything in the middle and rendering this. So I hope that you liked the video. Please leave a like, comment, subscribe, and if you need anything, I will be there for you in the comments down below.